in Introduction to Statistical Learning in R, Chapter 5. We're into the applied questions, and we're in question 7. Okay. So we're going to, in this question, we're basically going to build our own leave one out cross-validation algorithm or something, bit of code. So we're going back to a data set that we've seen in an earlier chapter called weekly, and we'll look at that data set. But the basic idea is that we had different lags so we were looking at stock market outcomes over many weeks, and so one of the variables in there was whether the market went up or down after a week, and as different possibly predictor variables were things like the autocorrelation of Lag1, Lag2, etc. Or I shouldn't say the autocorrelation, but the values of the previous weeks, Lag1, Lag2. Okay, so we're going to revisit that, and like I said, along the way we're going to build the leave one out cross-validation type of algorithm here. So I won't read everything here because we'll take them in turn. So first thing we want to do is to make sure that we've installed the ISLR2 package and loaded that package into R. And then we want to pull up the weekly data set, which is part of the ISLR2 package. And so I can do it with this, data weekly, and then I'm just assigning the label D to the data set weekly, and I can get the first few rows of D here with the head function, and it looks like this. Okay, so what we're going to have here, or the important things here, are going to be Lag1, Lag2, and direction. Okay, and we're going to try to predict direction with Lag1, Lag2. Okay, so we're asked to do this so before we get into doing the leave one out cross-validation, we're first just asked to run a logistic regression that predicts direction, whether up or down, based on Lag1 and Lag2. Okay, and so that's the code for that right there. Okay, no big deal. We won't really look at the output, but we could run that, and that's fine. Okay, so that's with the full data set. Now in part B, down here, we're asked to do essentially the same thing, but we are not training on the first observation, right? So we're not going to train on this observation. So our data set then will be everything except for the first observation. Okay, so to do that, I'm just going to say dtrain equals D minus the first row. Okay, so that means that the training set is everything from here down. Okay, and then the test set is just 1, it's just the first row, the thing that we omitted. Okay, so I can run that, and we're not really asked to look at the output, and the output really isn't all that interesting just yet. Okay, now part C, we're asked to use M2, or what I'm calling M2, the model that we just fit, to try to predict the first observation. In other words, to predict direction here in D1. Okay, so to do that, so I'm creating an object I'm calling M2 predict. So I'm using the predict function. I'm using the model2 M2 to predict it, and the new data is just d-test. And again, remember that d-test is just the first observation from our data set, and that was the observation that we omitted when we trained that model. Okay, so I'm going to predict it, and then if it's over 50% or more, or 50% or more, I say call it up. Otherwise, call it down, right? So predict is going to return a probability of being up or down. Okay, and I'm saying if with the outcome of this if-else statement, okay, or I'm saying sorry. So I'm saying if M2 predict is greater than 50%, call it up. Otherwise, call it down. And then that is part of this logical statement that says if that statement, the output of that statement, equals the actual value, in this case should be down, then tell me. So if that is a true condition, then it will come back true. Otherwise, it comes back as false. Okay, and in fact, it's false. So in other words, the model would have predicted that observation 1 was going to be up, but in fact, it was down. Okay, so it was an incorrect observation there. You know, we could probably even see that here. Let me Okay, so yeah, okay, so so the predict function predicts a 57% probability that the actual value is up. Okay, and because that's above 50%, it called it up, but in fact it should have been down. Okay. Okay, so now this is where we actually get into the leave one out cross-validation loop that we're supposed to write, okay? So we're basically going to do what we did in parts B and C, but we're going to loop over every observation. So in other words, so we've just left one observation out, but we're going to leave observation 1 out, train on everything else, and then try to predict observation 1. And then we're going to leave observation 2 out, train on everything else, and then predict observation 2. You know, all the way through every observation in the data set. All right. So so here's the code that I'm using to do that. Okay. So I just have this vector here that will take in values of true or false. All right. And it has in rows, or it has how many entries does it have? It has 1 entry for every observation in our data set. And so now I'm creating a for loop where with every turn of the loop, I'm creating a training set, which is just omitting the ith observation, and then a testing set, which is the ith observation. And that's the thing I'm going to try to predict. I run the model, okay, this time using dtrain. And again, dtrain is the truncated data set. And then I try to predict the omitted observation, okay, with this. And then I run my if-else statement, so it's going to be true or false, and then that's going to go to the results vector here. Okay. Part 4 here wants us to say if an error was made, call it 1, otherwise call it a 0. I'm using true or false, so you could mess with the code to get it to put out a 1 for an error and 0 otherwise, but that's not really critical to what's being asked here. Okay, so we're going to run this, and you notice that it takes a second to run because, again, for every observation, it's running through a model and then predicting it. Okay, so it's done. And so in part E here, we're actually going to look at what the test error is. Okay, and so the test error, I've already ran it here, that I'm calling test error is 1 minus the sum of the results. Okay. In fact, let me bring up what results looks like. Okay, so this is what results looks like. So I have a big vector of falses and trues, you can, so with logical vectors you can do arithmetic with them in R, where true is 1 and false is 0. Okay, so I'm taking all of the true results, so I'm going to sum all of the true results divided by the length of the results. Okay, so that will give me a percentage that I got correct. And so if I want the percentage that I got incorrect, I need to subtract the percentage I got correct from 100%. Okay, so and that gives me the test error rate. Okay, and so it's about 45% false. So about 55% it's guessing correctly. So that's just a little bit better than random chance. Okay, we'll call that good.